Hello, geometry students, and welcome to Geometry B. Whether Geometry A just ended for you or if it ended a while back for you, Geometry B builds some on Geometry A, but there's other concepts that you're going to combine things you learned in Geometry A with some algebraic rules, so with some rules from algebra. So you're going to have to keep those steady as well. And we start in Unit 6. We kind of get into what is a pretty meaty unit. We talk a lot about right triangles and kind of everything that can happen with a right triangle. So we start with something that you've obviously seen before, Pythagorean theorem, but we use it in a way that you're probably not used to. Okay, so we're just going to kind of start with what is it, how does it work, and kind of what are some of the things we can do with it. So Pythagorean theorem. All right, so Pythagorean theorem is, first and foremost, you have to have a right triangle. Okay, so that means you need to have a 90-degree angle. Okay, I don't know why it's doing that. So you need to have a 90-degree angle, okay, and you cannot use Pythagorean theorem without a 90-degree angle. So with a right angle C, so then my rule is just a squared plus b squared equals c squared. Okay, now a and b, these are called legs. Okay, those are called legs. And my long side, my side opposite my 90-degree angle, that's called my hypotenuse. Okay, so we're saying the sum of the squares of the legs equals the hypotenuse squared. Okay, so that's basically what the Pythagorean theorem is a squared plus b squared equals c squared. Okay, it's got to be in a right triangle, and that's it. Now let's start looking at what we're dealing with. All right, so now if I look at number 1, okay, 6 is a leg, 15 is a leg, x is my hypotenuse. Okay, and I'll just shorten that up to HYP for hypotenuse. So this would just be 6 squared plus 15 squared will equal x squared. I'll clean that up so it's a clear 15. So this will be 36, and this will be 225. So that will be x squared. Okay, so now it's just a matter of putting those two together, and you get 261. So now, final steps to solve is just square root both sides. So x will equal, as a decimal, it is 16.1, actually it's 16.16, rounded. Okay, so that's all that is. That's all I'm doing. That's all I'm doing. Number 2 over here, very similar. Okay, 17 would be a leg, 7 would be a leg. So I would have 7 squared plus 17 squared equals x squared. So that would be 49 plus 289 equals x squared. Okay, so that'll be 338 equals x squared. So square root. And if you left it as square root of 338, I wouldn't hate it. If you gave me the decimal, that would be fine too. Sorry, that's not x squared anymore. That's just x. There we go. So that's the pretty straightforward. Most students have seen that before in some way, shape, or form. I'm hoping this just kind of jogs your memory a little bit to kind of recognize what I'm dealing with here. So now if we change gears here a bit, this one, this is my hypotenuse. This is a leg, this is a leg. So it's going to look a little different. So it's going to be x squared plus 9 squared equals 11 squared. Okay, so now I've got a little bit more work to do. So just multiply those out. So I will get 40, square root. So x would equal the square root of 40. Now, if you left it as square root of 40, that would be fine. If you left it as 6.32, that would be fine. But if you recognize that, hey, I can simplify this, and you gave it to me in that answer, that would be great. That would be impressive. If you can simplify the square root, that would be very impressive. Okay, I would be very happy with that. Okay. Now, Pythagorean triple is merely three integers, okay, so three positive integers that work in Pythagorean theorem. So if you check 3 squared plus 4 squared equals 5 squared. Okay, so that's 9 plus 16, that's 25. Those two are equal. 5 squared plus 12 squared equals 13 squared. Okay, and likewise for 7, 24, and 25. But what I want you to realize is that I can take these numbers and I can take factors of those. And what I mean is if I have 3, 4, and 5, then 6, 8, and 10 will work. Okay, and then, so multiply by 2. Now if I multiply by 3, 9, 12, and 15 will work. 12, 16, and 20 will work. Okay, those are going to be common Pythagorean triples. So 5, 12, and 13, 5, 10, 24, 26, 15, 36, and 39. And if I have 20, 48, and 52, those would all work. Okay, so 7, 24, 25, well then 14, 28, and 50 all work as well. Okay, and you can keep that going. I mean, you can fill the rest of that out. But those are just kind of combinations of numbers to look for that might kind of tip you off that, hey, this is a Pythagorean triple. Okay, so now, flip side. So if I turn the Pythagorean theorem around, and I'm using it to check. So now, if a squared plus b squared equals c squared, then a triangle ABC is obviously a right triangle. Okay, that's obviously a right triangle. That's like by definition of Pythagorean theorem, okay? If it works forward, it works backwards. But now I can use Pythagorean theorem to help me out by figuring out other kinds as well. So I have a right triangle, okay? I can also figure out, is this an obtuse triangle? Or is this an acute triangle? And everything feeds off of whatever c squared is. Okay? Everything feeds off of c squared. So if c squared is smaller, okay, so remember that means less than. Okay, so if c squared is smaller than a squared plus b squared, that means a squared plus b squared isn't much, much bigger. C squared is smaller. That is going to create an acute triangle. Okay, that is going to create an acute triangle. If c squared is much bigger, you're going to have this situation. Okay, so c squared is much bigger. You're going to have this triangle situation. In that case, you're just going to say, you know what? That's an obtuse triangle. Okay, that's an obtuse triangle. So that's maybe a different wrinkle than you've seen before for using Pythagorean theorem, is being able to use it to kind of help identify, okay, what kind of triangle am I dealing with here? Okay. So now, let's kind of look. So if I test Pythagorean theorem and kind of compare the two, what do I got? So I've got, 7 squared plus 14 squared. So that'll be 245. Okay, then if I go 16 squared, that'll be 256. Okay, so they're not equal. Okay, this one is clearly bigger, so that means c squared is bigger. That means I'm dealing with an obtuse triangle. Okay, that means I'm dealing with an obtuse triangle. For B, so if I look here And again, I'm just running this through. 9 squared plus 40 squared, and then 41 squared. So 41 squared ends up being 1681. 81 squared, or 9 squared is 81. 40 squared is 1600. Those two are equal. So this is actually a right triangle. Okay, those two are equal. For the last one it's kind of tricky. It's kind of a twist because I have to kind of recall some things. Number one, 1 plus 7 equals 8. So this is technically not a triangle. Okay, because one of the rules is that any two sides has to be bigger than a third in order for it to actually be a triangle. So that needs to be one of these, either 1 or 7, has got to be a little bit bigger in order for that sum to be bigger than 8. So this is actually not a triangle. This is not a triangle. So that's what I have to say. I say this is not possible to get to be a triangle. Okay? So that's a good little review of a concept we've talked about before. All right, so now this is going to be a little trickier, okay, but we can still do it. We have to stick to our rules. So now, follow our rules. And this is going to bring in some algebra stuff, so I warn you now. Okay, so be prepared. All right, so I've got x squared, okay? So this is my hypotenuse. So x squared is going to equal x minus 5 squared plus 8 squared. All right? This will be a leg. This would be a leg. Okay, so now let's look and see what we got. So this is x squared. Okay, so now sidebar, x minus 5 squared does not equal x squared minus 25. That is not correct. Okay, you have to kind of think back to algebra rules and realize that it is x minus 5 times x minus 5. So it becomes x squared minus 10x plus 25. That's your correct answer. Okay, and if you're not sure, then I depending on how some people do it, I have kids, you can draw a little box and fill it in. X squared minus 5x minus 5x positive 25. These two go together. That's where I get my answer. So this is really x squared minus 10x plus 25. Then this 8 squared means plus 64. Okay, so now I have some x squareds. I have some other x's. I have a whole bunch of numbers going all around here. So let's clean this up. So x squared equals x squared minus 10x. 25 and 64 together is going to be 89. So now if I subtract x squared from both sides, both those zero out. So 0 equals negative 10x plus 89. So add 10x. So 10x equals 89. So x would just equal 8.9. There's my answer. There's my answer. There's my answer. Okay? This is a good review of multiplying binomials. Just a good little quick review. So now, quick word about this. Okay. The one thing that you need to be very, very picky about here, when they say simplify, this means no decimals. Okay, so it's not just throw this number in your calculator and hit enter and give me the answer. That's not what I want here. Okay, you need to start thinking about some things that I can work with. So I need to simplify. That means, so if I just take A, I'm looking for what is a number that I can split that also happens to be a perfect square root. So a perfect square root, 1, 4, 9, 16, 25, 36, 49, all those numbers that you should know. By the way, you should know all the perfect squares up to 15. if I do that, so 3, 4, 3, I should start looking to see if I can split those with anything. Okay, so nothing jumps out at me yet. So 343 splits into 7 and 49. So I can break that apart. Now, can't take the square root of 7, but I can take the square root of 49. So that just becomes 7. Then I still have square root of 7. There's my simplified answer right there. There's my simplified answer. That's simplified. Notice, no decimals. All right, for B, I'll push B over here. 192. I might have to play around with that a little bit, but I recognize that that is going to be 81 times 2. And I can take the square root of 81. I can do this one. Okay, that's just going to be 9. So it's going to be 9 times square root of 2. There's my answer. Okay, so that's what I'm looking for. I'm looking for what can I divide by that's one of those. So now letter C, 32. 32, let's see, I can go 16 and 2. So the square root of 16 is just going to be 4. So there's my answer. There's my answer. Okay, so you know, for this one, square root of 32. What if you automatically jump to 8 and 4? Okay, you're not wrong. Okay, you're not wrong. You might have to take an extra step because you can absolutely take the square root of 4. That is absolutely right. But what you need to recognize is that square root of 8 is also 4 and 2. Okay, so I can take the square root of 4, that's 2. I can take the square root of 4 here, that's 2. So I would have 2 times 2 times square root of 2, which would just be that. Okay, so an extra step, but you still arrive at the same place. Okay, so you're not wrong if you go that route. You might just have a little bit more work to do. Then finally, square root of 27, that splits into 9 and 3. And again, I might have to test a few just to see if it works. Take 27 divided by some things and see what happens. So that's just going to be 3 square root of 3. That's it. That's all I'm doing. Okay, so if the problem says simplify, you cannot give me a decimal answer. That's incorrect. Okay, that is not acceptable for what you've done. Okay, that is not an accepted answer. Okay, so what do? Well, you've done the 6-1 notes. Check. So now you do the 6-1 assignment. Then you do the 6-1 quizzes. Okay, and that should be in that quizzes app, and it should be assigned to you. You might have to look around for it. And then once you've gotten 100%, then you go to 6.2. Okay. Play around with some of these ideas and let me know what questions I can answer for you.